Hey guys, welcome to this video on exception handling in Python. We're going to have a look at what an exception is, how we can write our own exceptions, and how we can raise and catch exceptions. In programming, an exception is a signal that an error or any other unusual condition has occurred. When an exception is raised, the program execution stops. So there's a number of built-in exception types, which can indicate conditions like reading past the end of a file, or dividing a number by 0. You can also define your own types of exceptions to raise errors in your code when certain types of actions or incorrect input happen. I've got a Python shell open here, and first I'm going to quickly demonstrate some of the built-in exceptions in Python. A simple one is a 0 division error. Say I tried to do 5 divided by 0. As you can see, I get a 0 division error saying that I tried to divide by 0. So 0 division error is a type of exception. Another type of error is if I try to add a number and a string together. So say I tried to do 5 plus a. I get a type error saying unsupported types for operation plus between an int and a string. So the built-in Python library code for addition throws a type error when you try to add unsupported types. In Python, exception is a base class, and all these other kinds of errors implement this base class. The fact that we have this base exception class means that we can also make our own by simply making a subclass inheriting from the base exception class. When it comes to actually writing exceptions in Python, there's two main parts. The first part is the bit of the code that's meant to throw the error. We use the keyword raise to raise an exception, meaning stop the execution of the program if we reach that line of code. We also have another concept called try except blocks. This is a way that we can handle the errors. The syntax for this is to write try, and then within the try block, write the code which may raise an exception. If the code succeeds without raising an exception, it will skip over the except part and go straight to else. However, if function does raise an exception, then it'll go into except. So this is a way of making sure that an exception doesn't stop the execution of our program, but we can handle the exception appropriately. Let's try to do a quick example of this. Alright, so here I have a simple add function that takes in two numbers and returns the sum. I'm then calling this function in two places. So the first time I call it with two numbers. The second time I try to call it, I call it with a number and a string. So we're expecting to see a type error raised, just like we saw before. Let's try to run this code on the right hand side. So as you can see, the first time it prints out 15, and the second time it gives us a type error. Now let's try to use the try except block like we saw before to make sure that rather than stopping execution and giving the users an error, we'll catch the error instead and handle it however we choose. So since this line that does x plus y is the line that raises the exception, I'm going to wrap this in the try block. So I'll do try, and then indent this return x plus y line, and then except, where I'm going to print a message to the user saying, please enter only numbers. Now let's try to run the code again. So as you can see, rather than raising an exception, the code in our except block was run, printing out please enter only numbers. It also didn't stop execution when the exception was hit, and it proceeded to print none, since add of 10 and hello returns none. When I write a try except block, I can specify a specific type of error to catch. So if the types are incompatible between x and y, x plus y returns a type error, so I can write except type error to make sure that I'm only catching type errors. When I simply write try except without providing any types, except will catch all kinds of errors. It's good to specify a type of error to catch to make sure that you're not accidentally catching errors that you're not prepared to handle. You can also chain except blocks, so I can accept a type error and, for example, a value error. So say this code potentially raised both type errors and value errors, I can catch both in the same try except block. Alright, so we've seen how we can catch exceptions that are raised by built-in code in Python. Now let's take a look at how we can raise our own exceptions and define our own custom exceptions. So this is a find hypotenuse function that we saw in a previous video. So basically a function that takes in the length of two sides of a triangle and returns the length of the hypotenuse. As you can see at the bottom, I'm trying to call find hypotenuse with a negative number. Now obviously you can't have a negative side to a triangle, so this behavior shouldn't be allowed. However, if I run the code, as you can see, it's ignored the fact that it's negative and tried to compute the hypotenuse anyway. This is a perfect example of a case where you might want to use an exception. Essentially, exceptions are best used in cases where your program receives input that you might not usually expect. So a good example of a case where you might want to use an exception would be user input. So using an exception to check the value of user input before you pass that into a function. Let's define our own kind of exception called a Pythagoras exception to handle all the potential incorrect inputs we pass into this function. Like we briefly mentioned earlier, to define a custom exception, you create a class that inherits from the base exception class. So I'm going to write class, and in the brackets I'm going to write exception. So that means Pythagoras exception is a subclass of the base exception class. Inside this class, I'm going to override the constructor and make the constructor take in a message. I've also written a string method so that we can easily check the value of the exception. Now inside this find hypotenuse function, before we actually calculate the hypotenuse, let's check that the input isn't negative. So I've added a condition to check if a or b are less than 0. Now we want to raise a Pythagoras exception. To do this, we use the keyword raise, followed by the type of exception, and in the brackets to this exception constructor, we pass in the message. So I'll say side length should be positive. Great, now let's run this code again and see what happens. So as you can see, we receive a Pythagoras exception saying that side length should be positive. Now what if someone, instead of passing in a negative number, tries to pass in some other kind of invalid input, such as a string? Running this code again, you can see that we get an error on the line that tries to compare a to a number, since it says unorderable type string int, so this function couldn't accept a string. So let's add another condition to make sure that the input are both numbers. So I've added a condition checking that both inputs are ints. If they're not, I want to raise a Pythagoras exception. And in this case, I'm going to print a message saying make side length should be number. Great, so that's how you write a custom exception and how you can raise your own custom exceptions. The final thing we're going to have a look at in this video is how we can write PyTests for functions that raise exceptions and how we can assert that they raise an exception. So over on the right hand side here we have a test file designed for testing our find hypotenuse function using PyTest, which we saw in our last PyTest video. So basically we currently only have one test that works for a valid case where we've passed in two integers that are both positive. When testing, it's important to test for edge cases and test for invalid input to ensure that our function behaves correctly when invalid input is passed in. So let's write two more tests to test for the error cases of find hypotenuse. One if someone's entered something that isn't a number, and one if someone's entered side lengths that are a number but are negative numbers. So recall that to write a new test, we simply write a new function that begins with test underscore. So I'm going to make a function called test non-numerical. So I'm going to call the function with invalid input. I've only passed in one non-numerical value. When you want to write thorough tests, it's a good idea to create separate tests for passing in one invalid value, two invalid values, etc. But for the case of this video, I'm just going to write one non-numerical test. Now the aim of this test is to assert that find hypotenuse has given an exception. It's not possible to use the return value to assert that find hypotenuse gave an exception, since when an exception is raised, it doesn't return an exception, rather stops the execution at that point. The only way of detecting that an exception was raised is to use a try except block, and we want to make sure that we reach the except part of that try except. So let's demonstrate this. So find hypotenuse is our error-prone code. Let's put this inside a try, and then we want to catch a Pythagoras exception. Notice that I've written accept Pythagoras exception as error. So now this error is an exception type object that we can print access attributes or access methods on. What we want to do here is assert that the error message is equal to the message we passed in the case that it's non-numerical. So side lengths should be numbers. Finally, in the else case, we want to write assert false, since if it reaches else, that means an exception wasn't raised. But in this test, we want to ensure that an exception is raised when we pass in invalid input. So I'm just going to write assert false. Now let's try to run this test and see if it passes. Great, so it says 2 tests passed. We can do a similar thing to make sure that the function raises an exception if we pass in a negative side length. Alright, so I've just quickly added a new test which does the same thing but passes in negative values instead of a string value, and then when we check the message, we're making sure that the message is side length should be positive. So if I run this code, as you can see, 3 tests are passed. Alright guys, that's it for exception handling in Python and how to write PyTests for code that raise exceptions. Thanks for listening.